the second lecture of the day, and the title is Relationship Between Hypothesis, Procedure, and Confidence Interval. Of course, before now, we've already done confidence interval. I remember we did confidence interval, one-sided, which comprises of lower and the upper, and we also did two-sided. And of course, we just work on hypothesis testing. Okay, the one-sided hypothesis testing and two-sided as well. But you know what? Um, is there a relationship that exists between hypothesis or testing procedure and confidence or interval? Of course, I'm going to say yes. Different actually, even though mathematical difference exists, but I'm actually going to say they perform the same role. Okay, so you're going to see that in this lecture. Okay, now four of us want to start with two-sided interval. So with the two-sided confidence interval, of course, we got unknown parameter. Of course, the whole thing is going to start, well, with us trying to figure out the values of unknown parameter. And of course, if we want to do that, we actually, since we're going to be using sample information, we needed, an estimator, which is going to be a function of the sample. And of course, the estimator here, or theta cap, actually believe to follow normal distribution. Of course, I told you the other time, when you're working with the confidence interval, you're working with the hypothesis testing. We talk about the significance of large sample size. Okay, so the significance of large sample size is actually required because of the normality of you know the sampling distribution of the point estimator is expected to be normal. Okay, if you really want to construct confidence interval about it, or you want to test hypothesis about the values of parameter. Okay, so if we're talking about two-sided, if you take a look at this guy now, okay, that we're actually having a lower bound and the upper bound. Okay, so that's a two-sided confidence interval. So this guy now is actually representing, let me just say theta cap L, and this guy now represent theta cap U. So the lower and the upper. Of course, we know that the probability of the parameter, lies in the two interval is actually going to be equal to 1 minus alpha that I call, confidence level. Don't forget, alpha represent the level of significance, and of course, the level of confidence and uh, level of significance are mutually exclusive if you look at the mathematics here. Okay, so if I want to go from here to here now, okay, we can actually, do that, trying to, so which means another way of writing this is this guy here. Okay, and of course, what is in the parentheses in the absolute value. Okay, so that guy is more or less a z, which is believed to follow a normal distribution with a mean of 0 and a variance 1. Okay, I think you already know this. Okay, so um, you know, I just talk about two-sided confidence interval now, where I showcase the lower bound and the upper bound, can we also uh, see the lower one-sided confidence interval? So the lower one-sided confidence interval is what I'm showcasing now. Okay, having a general formula. Okay, the general formula here is I got theta cap L, okay, all the way to infinity. Take a look at that. So that's a lower one-sided confidence interval. And of course, if I want to figure how, the way I actually walk you through that of the two-sided the other time, it is the probability of the parameter, greater than, the greater than that. So forget, this guy here is actually theta cap head. Okay, and that probability now, so when you tried and simplify that guy, trying to subtract, like, if I want to rewrite that as theta cap minus theta divided by standard deviation, I can actually go from here to here because of the negative, the inequality sign is actually going to change. So that was why. So you can see that now. And if you take a look at this guy again, so that guy is a standard normal random variable that is believed to follow normal distribution with a mean zero variance of 1. So like I said the other time, if you take a look at this guy, like some of you may be wondering how we go from here, okay, to here. Initially I got theta greater than theta cap minus z alpha or sigma theta cap, right? Okay, if I want to write from the right hand side, I'm actually going to have a theta cap minus z alpha. Okay, this guy now, okay, now it's going to be less than theta. Okay, so if this less than theta now, so if this guy comes to this side, I'm actually going to have minus theta. Okay, less than this guy go to the other side, going to be z alpha sigma that, and all what you just need to do is to divide both sides, okay, by sigma theta cap. Okay, and when you do that, you actually, okay, you're actually gonna have this guy gonna cancel that guy, and that was why we got that guy now, okay, which is equal to the confidence level. Okay, that's a lower one-sided, and this is the upper one-sided. The upper one-sided is gonna start from negative infinity, okay, to this guy here, and of course this guy here is theta cap, okay, u, okay, and of course the probability of theta less than that, if you go all the way, we're also going to have that. So I think we've done this before in class, just trying to showcase, the different kind of interval we have before we can actually, try to see if there's any relationship between them. Okay, so let's now, since we've reviewed the type of confidence interval we have, now uh, I want to talk about, also want to review the hypothesis testing as well. Then we'll be able to see if they got relationship. Okay, now I'm going to first start with, take a look at this. I want to start with the two-sided hypothesis testing, where I'm testing that. And of course, the condition to reject, you remember the other time, the absolute value of z has to be greater or equal to z alpha over 2. And of course, this guy here is actually that. Now, do you know, we can actually have, we can take a look at this and solve. We can solve for theta naught. Okay, solving for theta naught. Okay, solving for theta naught. Okay, this is what we actually gonna get. okay, solving for theta naught. We're gonna have, you know, solving for theta naught, we're actually gonna get this now. Of course, right from here, don't forget if I actually don't forget you have absolute value of x, for instance. The absolute values of x could be negative x, could also be, so if you really want to know, if you want to remove the absolute value, what you have inside that could be a negative x or a positive x. So now when you take a look at this guy now, so which means, okay, equivalently, okay, we reject the non-hypothesis conducting two-t test if the absolute value of that is greater or equal to that, or we can also say, if I want to use the values of theta naught, don't forget the values of the theta naught is an hypothesized value, right? Now, we're also going to have, conditions like, okay, I'm going to reject if theta naught is less or equal to that, or is theta naught greater or equal to that. So which means when theta naught is less or equal to, this is like a theta cap lower, okay? When theta naught is less or equal to theta cap lower, or, it is greater or equal to theta cap upper, okay? That's what we mean. And that is where we're going to reject. So if you want to look at it graphically now, okay, looking at it graphically, we actually going to reach, did you say rejection region? That's another rejection region, and whatever that comes in the middle here is actually going to be acceptance region. Take a look at that. So which now means, if I'm conducting hypothesis cell testing, okay, so if I'm conducting hypothesis testing now, that I call two-sided, okay, I'm actually going to reject if that's happen. So I needed to take a look at that. So which means if I want to use the idea of a confidence interval now, so which means if theta naught falls outside, if it fall out of the two-sided, okay, this guy is falling out of the two-sided. Imagine a situation where the theta naught is less than the lower, is less or equal to the theta cap lower, okay, or is greater or equal to theta cap upper, that is falling outside, okay. So falling, when theta naught actually fall outside the two-sided, okay, of the interval, of course, it means we actually gonna reject the non-hypothesis. So what it means is if you, instead of you to conduct hypothesis testing, but you want to base your decision on the confidence interval, if you obtain your lower bound and the upper bound, then the only condition to reject is when your theta naught actually fall outside, the boundary. So, which means if it fall outside the boundary, you of course is the same. You can actually use idea of that to take a decision regarding hypothesis testing. Okay, which means in other words, you're actually going to fail to reject. So if this is rejecting, automatically this is the failing to reject. Can see that's a complement of that. And of course, acceptance now is actually the confidence interval itself. This is a normal confidence interval, okay, which I've described here. That's a normal confidence interval between, when they fall between, uh, when the theta naught fall, in that very boundary of a lower and the upper, of course, we're actually going to fail to reject the non-hypothesis. But the moment it fall outside, okay, the confidence interval, we actually going to reject the non-hypothesis. You can see the relationship now between a two-sided test and a two-sided confidence interval. Okay, so I'm actually going to move now to one-sided, and I'm going to start with upper one-sided test. Of course, what determines the name of the test is what you got at the alternative hypothesis, the alternative hypothesis here is actually theta greater than theta naught. Okay, now based on what we've done before, the condition to reject the non-hypothesis is actually when z, okay, this guy is going to be z, don't forget, which follow normal the distribution, which means 0 1 has to be greater or equal to alpha for upper one-sided test. And of course, if I actually want to solve for theta naught, because the idea of solving for theta naught is to be able to use one-sided confidence interval in taking decision here. Okay, when I solve for that, of course, this is what I got, solving this mathematically, don't forget you're actually solving, okay, for theta naught. Okay, so solving for theta naught, okay, the only condition to reject the non-hypothesis now is if your theta naught is less or equal to that. So theta naught, okay, less or equal to theta cap, okay, lower. That is what it means. Okay, now you're actually going to reject, okay, which means theta naught fall out of the one-sided, because when you take a look at the one-sided confidence interval that we talked about before, okay, the one-sided confidence interval for lower, if you take a look at this is one-sided confidence interval for lower. You remember I showed you the other time, which is more or less like this to infinity. That is one-sided confidence interval for lower. Okay, that is lower one-sided confidence interval. So what we actually mean here is, okay, if theta not fall out of the one-sided, okay, if theta not fall out of the one-sided, because when I say out of the one-sided here, okay, is theta not less or equal to that, and don't forget it's starting from here, so less or equal to that. That's what exactly what we mean. And of course, we're going to fail to reject, okay, the complement of this is actually of this guy now. So failing to reject is when it actually fall inside, okay, so which means if you are talking about one-sided upper test, okay, and you want to use the idea of confidence interval to take a decision, or regarding that, you're actually going to use lower one-sided confidence interval. Okay, I'm going to say that again. You're going to use lower one-sided confidence interval to take a decision regarding upper one-sided test. I'm going to say that again. You're actually going to use a lower one-sided confidence interval to take a decision regarding the one-sided, regarding the upper one-sided test. So please take a look at that. So upper one-sided test, when I'm conducting upper one-sided test, and actually if I want to use a confidence interval to take a decision, the confidence interval that I'm actually going to use is going to be lower one-sided confidence interval. And I'm actually going to reject the non-hypothesis if theta naught actually fall outside of that, and with theta naught fall inside of the lower one-sided confidence interval, we actually going to fail to reject. Okay, so can we move now to lower one-sided test? Take a look at that. It's called lower one-sided test because the alternative is actually saying theta less than theta naught. Okay, and based on the critical region, what we did in class, of course, we actually going to have that guy. The condition to reject the non-hypothesis for that is going to be when that guy is less or equal to negative z alpha. If you want to now use the idea of a confidence interval to take a decision, now you needed to solve for theta naught. Okay, now the theta naught is actually that, and what that means, you are going to reject the non-hypothesis, okay, if the theta naught is greater or equal to that. Now what are you going to use here? You're actually going to use upper one-sided. Okay, this is an upper one-sided, okay, which is going to be from this to theta cap upper, okay, to theta cap upper, which is this guy here. Okay, so take a look at that. So now, if you want to take a decision now, okay, if I want to take a decision regarding the lower one-sided test, I'm actually going to use upper one-sided confidence interval. I'm going to say that again. If I want to take a decision regarding a lower one-sided test, I'm actually going to use upper one-sided confidence interval. And when my theta naught fall outside of that, I'm actually going to reject. When I theta naught fall outside that, don't forget, how do we know? Because the theta naught here is greater or equal to that. So, and this guy, I think for you to be able, I think this guy is supposed to be like a close interval, okay? Sorry, but that should be a close interval. Okay, if you take a look at this, we're trying to say that if that is greater or equal to that, it means it falls in the upper one-sided, then we are actually going to reject the non-hypothesis. Otherwise, if it falls, inside that, we're going to fail, okay, to reject. So take a look at that. Okay, so I'm going to walk you into an example, but this example has to do with two populations. Okay, we got two groups. Okay, and you know what I want to do? I actually want to use confidence interval to take a decision here. But yeah, I'm having two groups, and not only that, I'm working with a two-sided test. And you know what? If I'm working with a two-sided test, okay, and I got two groups, okay, which is I'm actually looking for the difference of means, right? If I'm looking for the difference of means, of course, we're actually going to use a different scenario here. So we're going to use a different strategy. The strategy is just going to be, if I construct an interval and there is zero in the interval, then we can actually say there's no significant difference. So which means we're actually going to fail to reject the non-hypothesis if there's a zero in the interval. But if there's no zero in the interval, of course, it means no zero in the interval is an indication that the non-hypothesis should be rejected. Okay, like I said, it's a two population. Okay, the one I explained the other time. Okay, this guy here is one population. Here is one population, and one population. The only way we can reject the non-hypothesis here is when the theta naught, the hypothesized value fall outside, of the confidence interval. You understand what I mean? This is for the one population, okay? But right now, what I'm dealing with in this example is two population. We are actually having men and women. The question is about, we got a psychological study was conducted to compare the reaction times of men and women to a stimulus. Independent random sample of 50 men and 50 women were employed in the experiment. The results are shown in the table, as you can see. And we got a research question here. Do the data present sufficient evidence to suggest a difference between the true mean reaction time from men and women? Okay, and they wanted to use alpha to be equal to 0.05. And of course, this is a hypothesis under investigation. Okay, and of course, we're going to have a z-test, okay, where we're going to make use of the formula that I've given you before. All what you just need to do is to plug in. We already have your data given here, okay? And of course, don't forget we got a zero here because the difference between the two population mean under the non-hypothesis is actually zero. And of course, at the end of the day, our z statistics was negative 2.5. And don't forget, because we're dealing with a two-stage test, if you want to go by the rejection region, okay, we're actually going to reject just if the absolute value of a z greater than z alpha over 2. And of course, when you check the z alpha over 2, okay, from the statistical table, where alpha equal to 0.05, you're actually going to have 1.96. For those of you that use R, you can actually do Q norm into 1 minus alpha over 2. Okay, you're actually going to get 1.96. And of course, when you take the absolute value of negative 2.5, that would be 2.5, right? And by the time you compare the absolute value of that, which is going to be 2.5, with the value you check from the table, because that is greater, then you're actually going to reject the non-hypothesis at that level of significance, rejecting the HO now. Okay, what it means is a significant statistical difference actually exists between the true mean reaction time for men and women at that level of significance. Now, if I want to take the same decision using hypothesis testing, using confidence interval, this is hypothesis testing. We just took a decision right now. Okay, can we also, we want to see if we actually construct a confidence interval, are we likely going to take the same decision? And I'm going to say yes. Now, what I'm going to do, this is a confidence interval. This is the formula. If you plug all that in, you're actually going to see here you have your lower bound is negative, your upper bound is negative, and let me tell you, if the lower bound is negative, the upper bound is negative, then we're not going to have zero in the interval. I told you the other time, the only way you can have zero in the interval is when the lower bound is negative and the upper bound is positive. The moment you got negative to negative or positive to positive, what that means is there's no zero in the interval. If there's no zero in the interval, that is significant. So that means the null hypothesis will be rejected. And that was why I said zero does not lies in the interval. When zero doesn't lie in the interval, you're actually going to reject the null hypothesis at that level of significance. Okay, so this is where I'm actually going to stop today. Okay, make sure you all stay safe and have a lovely day. So bye for now, everyone.